Welcome to the AI on AI podcast, where we delve into the most cutting-edge topics at the intersection of artificial intelligence, business strategy, and technology leadership. Today, we're tackling a fascinating and highly innovative topic, Foundation Model Self-Play, or FMSP, a new approach that combines the power of foundation models with self-play to discover creative strategies and solutions. Joining me today are some of the brightest minds in AI and business strategy. Let's dive right in.
Thanks for having me. I'm really looking forward to this discussion. FMSP represents a unique convergence of AI techniques, and I think it has the potential to unlock some groundbreaking applications.
Absolutely, Expert 1. Let's start with a quick overview for our listeners. What exactly is Foundation Model Self-Play, and why should business and technology leaders be paying attention to it?
Great question. At its core, FMSP is a way to leverage the generative power of foundation models, those large-scale, pre-trained AI systems like GPT for multi-agent self-play. Traditionally, self-play involves two or more agents competing or collaborating in a simulated environment to improve their strategies over time. What's unique here is that FMSP uses foundation models to generate not just single-agent policies, but entire ecosystems of diverse, code-based strategies. To add to that, it's like having two AI software engineers in constant competition, each trying to outdo the other by crafting better and more novel strategies. And these engineers have access to the vast knowledge encoded in foundation models, so they can pull ideas from fields as diverse as robotics, game theory, and natural language processing.
That's a powerful analogy. Expert 3, you've worked on large-scale AI systems. What do you think about the scalability of this approach?
Incredibly promising. One of the traditional bottlenecks in self-play has been the computational cost of running simulations, especially for complex tasks. By operating at a higher level of abstraction, generating code-based policies rather than low-level actions, FMSP can explore a much larger solution space without getting bogged down in computational overhead. Plus, the use of foundation models means we're starting with a knowledge base that's already vast and richly contextualized.
If I could jump in here, one of the things I find most exciting is the hybrid approach of FMSP variants, especially the Quality Diversity Self-Play, or QDSP. It combines the focused optimization of traditional methods with a broader exploration of the solution space. It's like using a flashlight and a floodlight simultaneously to navigate uncharted territory.
That's a vivid image, Expert 4. Let's talk about some of the real-world applications of FMSP. Expert 5, as someone deeply involved in strategy, where do you see this technology making the biggest impact?
The potential applications are vast. In business strategy, for example, FMSB could be used to simulate competitive markets or optimize supply chain logistics. Imagine having AI agents that can autonomously discover innovative ways to reduce costs or improve service delivery. And in technology, the implications for AI safety, cybersecurity, and even software development are equally profound.
I'd like to build on that. In cybersecurity, FMSB could revolutionize how we think about threat modeling. Instead of relying on human experts to manually identify vulnerabilities, we could have AI agents that continuously probe and patch systems, effectively creating a self-healing cybersecurity framework.
And let's not forget the potential for innovation in areas like robotics and gaming. The car tag example highlighted in the research shows how FMSP can discover strategies that even domain experts might not have considered. It's like creating a sandbox for perpetual innovation.
Speaking of car tag, let's dive into the technical details. Expert 2, could you break down how FMSP approaches tasks like this?
Sure, in the car tag example, FMSP was used to evolve both pursuer and evader strategies in a continuous control environment. The system started with simple, human-designed policies and iteratively improved them using three variants: vanilla FMSP for direct optimization, novelty search self-play for exploring diverse strategies, and quality diversity self-play for balancing performance and diversity.
What's particularly interesting is how these strategies emerged. For example, some of the evolved policies used techniques like Monte Carlo tree search, Kalman filters, and even genetic algorithms. These aren't just tweaks to existing strategies, they're entirely new approaches generated autonomously by the system.
That's fascinating. Expert 4, you mentioned earlier the hybrid nature of QDSP. Can you elaborate on how it balances exploration and exploitation?
Absolutely. QDSB employs a two-step process. First, it generates new policies by asking the foundation model to create something interestingly new. Then, it evaluates these policies against an archive of existing solutions. If a new policy is novel and performs well, it's added to the archive. If it's not novel but outperforms similar existing policies, it replaces them. This ensures that the system doesn't just wander aimlessly, but also doesn't get stuck in local optima.
Expert 5, from a business perspective, how do you see organizations leveraging this balance between exploration and exploitation?
It's a game changer for innovation. Many organizations struggle to balance incremental improvements with breakthrough innovations. FMSB provides a framework for doing both simultaneously. Imagine using QDSB to explore new product features while optimizing existing ones, or to test different market entry strategies in parallel.
That's a compelling use case. Now, let's talk about challenges. Expert 6, what are some of the hurdles we need to overcome to make FMSP more widely applicable?
One major challenge is alignment. While FMSB can generate highly creative solutions, ensuring that these solutions align with human values and organizational goals is critical. Another challenge is computational cost. Although FMSB is more efficient than traditional self-play, it still requires significant resources, especially for large-scale tasks.
I'd add that interpretability is another hurdle. The policies generated by FMSB can be complex, and understanding why a particular strategy works or doesn't can be challenging. This is especially important in high-stakes applications like AI safety or cybersecurity.
Those are important points. Expert 1, what about the ethical considerations? How do we ensure that FMSP is used responsibly?
Ethical considerations are paramount. For example, in the Gandalf case study, FMSB was used to both attack and defend large language models. While this showcases its potential for AI safety, it also highlights the dual-use nature of the technology. Governance and transparency will be key to ensuring that FMSB is used to benefit society rather than harm it.
Very true. As we wrap up, I'd like to ask each of you for a quick takeaway. What excites you most about the future of FMSP?
For me, it's the potential to discover strategies that humans wouldn't even think to explore.
I'm excited about the scalability and adaptability of this approach. It feels like we're just scratching the surface.
I think FMSB represents a paradigm shift in how we think about innovation, balancing exploration and exploitation in a way that's both systematic and creative.
From a business perspective, the ability to simulate and optimize complex systems autonomously is a game changer.
I'm most excited about its applications in AI safety and cybersecurity, creating systems that can defend themselves in real time.
For me, it's the open-endedness, the idea that FMSB can keep learning and improving indefinitely.
What an inspiring discussion. Thank you all for sharing your insights. FMSP is clearly a technology with transformative potential, and I can't wait to see how it evolves in the coming years. To our listeners, thank you for tuning in to the AI on AI podcast. Until next time, keep exploring, innovating, and pushing the boundaries of what's possible. The research introduces Foundation Model Self-Play, FMSP, a new approach leveraging foundation models for generating diverse and high-quality strategies in multi-agent settings. FMSP overcomes traditional self-play limitations, such as lack of diversity and convergence to local optima, by harnessing code generation capabilities of foundation models. 3 variants of FMSP are explored: Vanilla Self-Play (VFMSP), Novelty Search Self-Play (NSSP), and Quality Diversity Self-Play (QDSP). VFMSP focuses on improving performance through competitive self-play, while NSSP prioritizes generating diverse strategies without considering performance. QDSP combines the strengths of both approaches, balancing diversity and quality by integrating novelty-seeking and performance refinement. FMSPs are evaluated in two domains: car tag, a continuous control pursuer-evader game, and Gandalf, an AI safety puzzle involving large language model (LLM) jailbreak defenses. In car tag, QDSP and VFMSP outperform human design policies, discovering sophisticated strategies using reinforcement learning, tree search, and predictive algorithms. QDSP achieves the highest exploration and quality balance, generating a wide variety of effective policies in the car tag domain. In Gandalf, FMSPs successfully evolve attackers capable of bypassing multiple levels of LLM defenses, showcasing the approach's adaptability in text-based environments. QDSP-generated attackers demonstrate innovative strategies, such as encoding secret words or manipulating prompts to bypass model guards. Defenders are also generated by FMSPs, effectively patching vulnerabilities and adapting to discovered attack strategies. The iterative attacker-defender dynamic highlights FMSP's potential for automated red teaming and improving AI safety mechanisms. Limitations include difficulty in solving the most complex Gandalf defense level, requiring future work on integrating multiple strategies. FMSPs rely heavily on foundation models for training knowledge, which may limit performance in domains with less representation in training data. Implications include advancing open-ended learning, enabling automated discovery of creative solutions, and improving AI safety through continuous adversarial testing. Future directions involve scaling FMSPs to more complex multi-agent environments and integrating neural network policies with code-based strategies. The work represents a significant step in leveraging foundation models for creative and open-ended problem-solving in multi-agent systems.